announcement first before we introduce our next keynote speaker. We have a rich social program in the conference. Today we have a trip to Amman, to the Citadel, and then to downtown for those who are interested to join us. And tomorrow we have the gala dinner at the Dead Sea. You need to register for the gala dinner. So please, if you are interested to join us in the gala dinner, register your name at the reception desk. On Saturday, we have a trip to Petra for those who are interested as well. And again, you need to register your name. So please, if you are interested, register your name after the keynote speeches now, like in 1 hour time. Okay? Now, it's my pleasure to introduce Dr. Arafat to introduce our next keynote speaker.
Thank you very much, Edward. So,
لا جيد. يعطيكم العافية. Thank you very much for being with us. It's my pleasure to introduce Professor Christian Boitet. Christian Boitet is a professor at the University of Grenoble, Alpes. Main research interest of Dr. Boitet is natural language processing, machine translation. Dr. Boitet is one of the figures really in natural language processing, and he worked a lot on developing UNL for people who are familiar with the natural language processing. He was the supervisor of 3 or 4 Jordanians during their study in Grenoble. We are very happy to have Christian with us. Dr. Christian, c'est vraiment mon plaisir de voir
merci infiniment.
L'opportunité de parler avec vous et de vous présenter à nos collègues d'Amman, Inch'Allah. We can start now.
Thank you very much. So this is the title, ambitious project to enable communication between 320 languages, say 20 years from now, and actually I will go very fast through some slides in order to give you some indication about the real content of the proposal we have started. So, of course, I would like to first thank you, Dr. Arafat and PSUT and Mohamed Daoud for this kind invitation. Okay. And the vision is not only to ensure communication between 320 languages, but also to add something at the level of the semantic web, in a way to equip text and messages, if possible, with companion files containing annotations which would clarify the existing ambiguities and the way you should translate them, in a way, some approach to guaranteed meaning communication. Okay, so Google Translation has already 103 languages and 320 or 314. This is the number of languages spoken by 90% of the world population. Okay, and I have added some ancient languages that have a lot of text into them. And the question is, can we use deep learning to really scale up in the number of languages, etc. I will mention briefly a theoretical obstacle, which I call CAQ theorem. And there is certainly a practical obstacle, the number of pairs. You know, it's quite enormous with the 103 languages by Google. But if you have 320, it's much more, it's quadratic. So, of course, the idea is to use something as a pivot, and I will advocate a semantic pivot representation to act as some intermediate representation of meaning. And we should use machine learning in the absence of experts. Okay, so also we have to know that if we want to get high quality, we will have to introduce some human participation. Okay, So we have in our lab some long-standing interest for under-resourced languages, with somebody, Vincent Bermond, having done all tools for Lao text and also computerized Lao French, French Lao dictionaries, etc. And one motivation for us in France is that Africa, with its many, many languages, will become the largest French-speaking territory very soon, 20 years from now. Okay? And then they have, in many countries, French or English or both, and lots of other languages. Plus, now we have Chinese coming there and establishing communication, etc. So it makes a lot. Huh? And for instance, in Cameroon, we have 288 languages. They are all on internet if you want. So you can write them, etc. But actually, they are more spoken than written. And people want to conserve their language, to learn and to use them on internet and to use them for communication. Well, only 86 of them have some kind of computerized resources, like dictionaries or whatever. So we start from low level. Okay, now I said something about quality. You know, translation that should be good enough, and I will skip it because to define quality in translation itself is very difficult, and it's not the same evaluation you have in different situations, and not the same kind of criteria you use if you do written translation and oral interpretation. Okay, so now altogether, what can be really automated? We want to automate as far as possible, but how? So in English, machine translation is actually ambiguous because it's like chair, you know, a chair designates a general kind of seats, and also a chair like those ones, some of them somewhere, without armchairs. So you have chair, chair, armchair. So you have this machine translation, and also automated translation on NT2. And yeah, sorry, I made a mistake. Here. Okay. So anyway, you see that there is a kind of different. Sorry. Yes. There is quite a variety of ways to let machines and humans interact in a way that Martin Kay wrote a very nice study in '65 that was published actually in '80, but the proper place of man and machines in translation. Okay. So I mentioned this theoretical obstacle. The theoretical obstacle is a kind of thesis, like a church thesis that you cannot prove mathematically, but that is experimentally true. That is, if you have 3 criteria of coverage, automaticity, and quality, measured in percentages, you cannot have the 3 of them at 100%. But you can get 2 of them at 100% if you compromise on the other, on the third one, okay? So if you want to have full coverage and automaticity, then you have web translators, and the quality is low, intrinsically. It is in the nature of the problem. Now, if you have automaticity and quality very high, that happens, it does happen, and those systems translate better than humans. But then, of course, the coverage is very restricted. So you work on restricted sub-languages like flash reports in the Nikkei or weather bulletins in Canada, etc. Okay? And if you have quality and coverage, very, very large thing, well, you cannot have total automaticity. You must actually get information in the heads of the authors or whatever, and even on the person who receives the messages. Okay. So now automaticity, can say we measure that by some formula comparing the time it takes to use a tool like machine translation and to do everything by hand. So typically 1 hour per page for a first draft by a human translator, but we can go down with post-editing to 15 minutes per page, 10 minutes per page, 5 minutes per page in some cases. And that gives me some kind of quality estimation, task-related quality estimator. For coverage, I skip. Okay, I will very quickly show you a bit of the domain. Many people think that, you know, machine translation is one problem. It's writing to solve an equation for one sentence out of context. What is the most probable translation? You know, argmax something. But that is not true. There are many translation situations, and okay. So also, if you see the machine translation systems, they are built around 3 levels of architectures, not simply rule-based and statistical, as people say. So I will give you a bit of information about that to clarify our minds. Okay, so also it must be understood that operationally, when you use machine translation for something, it is a small module embedded in many other things. Here, this is an example from the workflow when you translate a document, 200-page document, for instance. Okay, you can see that there are many operations there before you get the final document in the target language or languages. So when it comes to linguistic architectures, we use to represent that Vauquois triangle. And we mean here the sequence of intermediate representations of the unit of translation, sometimes one sentence, sometimes one full paragraph, sometimes a full text, okay, like a full XML document. Okay, and then computation architecture, this is the way we compute the transitions between, or the passages between one representation and the next. So this is here the possible linguistic architectures. So you have here, I made a mistake here. Yeah, here you have various levels of linguistic representations here, where only the one here is really language independent, but at some, say, interlingual level, you still have a presentation that contains a lot of information that is interlingual, but also some information that is more related to the surface. If you have syntactico-functional level, then you have, how to say, constituents or syntagmas like nominal phrase, etc. You have also syntactic dependencies like subject, object, complement of object, complement of subject, etc., etc. Okay, and you can also have representations where you mix the levels. Those who are the favorites of Bernard Vauquois, where actually you have information that belongs normally to semantic level, sometimes pragmatic level, etc. And then here you have the path. So this is, for instance, syntactic transfer. You do some kind of step here, where you do maybe morphosyntactic analysis and then syntagmatic analysis, or you do both together. Okay. Then you do a syntactic transfer. So you transfer syntactic trees of source language into corresponding ones of the target language, and you also do some lexical transfer, bilingual correspondences, and you generate. Okay, all those here have been implemented in running systems, not only in prototypes. Okay, now where can the human help here when I spoke of interaction? Well, at many places, but basically inside a step, say during, for instance, syntactic analysis, whatever, or between. Okay, when you produce some structure that contains a representation of ambiguities, and then you can have the human intervene by some sort of dialogue, of direct intervention, or whatever. Okay, and okay, we had lots of systems where there is some man-machine interaction during the process. Okay. So now for computation architectures, the choice is not simply rule-based MT and empirical MT. That's not true. Some parts, like some morphological analysis, for instance, can be itself built using some expert approach by putting rules and coding the paradigms, etc. And of a hybrid way, the data dictionary can be largely, extracted from existing dictionaries, terminological lists, etc., and from corpora in some kind of empiric way that is corpus-based. So the same phase can be and can operate being driven by rules, but also by other data like dictionary that can be learned in some hybrid way. Okay, so when people say RBMT, they imply that all steps, all phases of a translation system are built in an expert way and with a rule-based language, programming language. Well, that is just almost never the case. It is sometimes the case. Okay, and you see you have very different ways of programming. Rule-based is one of them, but they are very different kinds of rule systems. And you have also procedural one, like morphological analysis of Japanese has been done directly in C for 30 years or more. But of course, now there exist systems that are rule-based and they have external specialized languages, like for Juman and Chasen, etc. Okay, and for empirical, again, there is a choice. Before people thought, oh, it's only SMT. So now I had no time to put NMT, neural MT there, but this is another kind. And EBMT is example-based MT, and the difference is that the examples are used directly during translation. The examples being, they can be annotated or raw. Okay, a lot of choice. Okay, so our guidelines are to use deeper linguistic architectures than is done in the most translations, machine translation systems, to use hybrid computation architectures. There's no one best solution for all problems, right? And it can also depend on the people who are there to build the systems, because for some, like analysis and conversion, sometimes we get the same results in percentages by using the statistical approaches, machine learning approaches, or expert approaches. In the C-STAR project of dialogue translation, and with our friends in Italy, they used a machine learning approach. We used a direct programming approach in TKL-TK. We got the same percentages of success. So it's a matter of taste, of know-how, etc. Okay. So, and of course, we have to use more machine learning. So here I show you a bit of what defines the criteria to define some operational situation. I forgot some things here, but okay, what are the users? What are the goals? Can be very different. What is the graph of the translations? So we are here interested in communication between N languages, but for instance, Microsoft translates into 62 different languages, and Mozilla in more than 100, IBM in 40 or 45, I don't remember. Okay, so this one into N, but DARPA, etc., or the intelligence agencies, they want to get information from many languages into their language. Actually, that was the first source of funding for machine translation. Translate from Russian into English, and in France, of course, from Russian into French. Okay, and the possible involvement of humans is also quite important to define the operational architecture, okay? Plus, of course, I forgot, but the available resources. If you have 11 years of translation memory, you can really build fantastically good translation accelerators like Bruno Pouliken has done for the United Nations in Geneva. But if you have, say, an under-resourced language or even language pair, well, you don't have those corpora, you would have to build them, and that has a cost. Okay? So, I want to show you that those very, very quickly, that the architectures are independent. That is, you may have any kind of linguistic architecture mixed with several kinds of computational architectures for the different steps. Here I have put you know, the different steps here. You see rule, statistical, and analogical for direct translation. Is it okay? Yeah. Ah, sorry. Okay. Now, if you use another kind of linguistic architecture where you go to a syntagmatic level and you project in a way like in Metal, like in LMT, McCord. You see you have lots of rules here, but you have also for morphological generation, for instance, procedural aspects here. And if you take horizontal transfer, where you produce something of the same kind as input, then it is just also the case that you find rule-based systems all over the place, but here you have post-processing and tree flattening that is statistical. And if you take conceptual transfer systems, it so happens that I know only rule-based systems there, fully rule-based systems, but using machine learning and example-based is also a possibility. Okay. Now, if you go to systems that go to knowledge-based interaction with the knowledge-based, etc., so again, you find rule-based systems and statistical systems. In particular, a very interesting Master 1 system presented by IBM in 2003 was fully developed by statistical methods, aligning surface utterances with a very specialized kind of interface format linked with a task. Okay, so something really semantico-pragmatic nature. Okay. Okay, and according to the operational architecture, they can, in a way, influence your choice of linguistic architecture. So, for instance, if you want to combine, to have translation between many languages, it stands to reason that, that when you have a system from L1 to L0, L0 is very often English, and from L0 to L2, then you should be able to combine corpora with very short sentences in average, like the BTEC, Basic Travel Expression Corpus, or Meteo or Alt-Flash. Alt-Flash is for the Nikkei, that's the system translating the flash reports, okay, from Japanese into English. And if you take something 25 words per sentence, well, you find that it's much more costly to do that. So it will influence our choices, okay? So which architecture to choose to handle 300 languages at the same time? So operationally, we know that we cannot have experts to build grammars, large dictionaries, etc., like we had before for a very few languages, very few, less than 10. Okay. So what we can is to motivate the speakers of those languages to translate. This usually people know how to do, even if they have done no studies in linguistics, etc. And we can build morphological processes very often for languages that have a rich morphology, in particular flexional morphology. That's a must. And you don't really learn the morphology of Finnish or Swahili or whatever, or Tamil or whatever, from example, because you have no examples. You have no annotated corpora, but you have very good books explaining you the morphology. So this is something you must build in some expert way, but also try to get the dictionaries out of the work of translators. Okay? And I think we have to use machine learning. It has been done before to learn the correspondences between, say, the text roughly speaking, and intermediate representation, and from them produce, so analyzers and generators, and converters and deconverters. And as far as linguistic architecture is concerned, I will demonstrate to you that yes, really, it makes sense to use something like UNL because all the textual representation is really error-prone and introduces new ambiguities. And if we take surface structures, etc., prepared by linguists, they are much too complex to be understood and manipulated by developers. Okay? So here, I will stop a bit, but look, this is a concrete multi-level tree. That is, I have information about many linguistic levels for the sentence. The customers were not given their money back by the cashier, but by the waiter. Here I have 20 nodes, and the nodes are complex, right? And it is done here in such a way that if I read the frontier, the leaves here, in a way this is aligned with the words one by one here. Or sometimes if you have compound word, you would have two nodes right there. But basically, this is quite complex. And to understand, and it will be different from language to language, and you have to know the, okay. So you might want to use an abstract structure. So if I put articles, etc., as features in the node, and I put the parts of the compound verb to give back together, etc., I get something like this, which has 14 nodes only. It's easier to understand, but now it is not projective anymore, right? Still, I claim too complex. You need several years of study of linguistics, etc., to work with that. Plus, they will be different from language to language, from language to language. Okay? And it will be difficult to take those of English as a basis because they are so difficult to understand. Same thing with the so-called logical forms of Microsoft. Plus, it's a problematic because they are proprietary. So this is where UNL comes in. And here, for the same sentence, I show you a diagram, which is a graph here, not a tree, with a reentrancy here. Okay? It has 5 nodes. And I can teach engineers, not linguists, to read UNL, that is to deconvert this into a sentence in 1.5, and in another 1.5, I can teach them how to encode, how to do that by simply translating in their head into English and producing the graph. So in a way, this is an Anglo-semantic structure containing also some pragmatic features if we can compute them or put them. Okay, so the discussion, what kind of pivot might be used, I have given some arguments against everything but UNL until now, so I skip. And we know that a good interlingua should have an autonomous vocabulary of word sensors. I think that's really essential. Like the Atlas II system, like the Ultra system of Wilkes, etc. Like all systems based on IF for particular kinds of restricted tasks. So we should have semantic properties and relations that as universal as possible. Pragmatic attributes, attitude of the speaker, etc. Politeness. Independence, and some independence from word order, because that's the main source of difficulty between languages. So we would like to have a presentation that can be, in a way, aligned with different versions in different languages of a sentence, you know, without having to be coerced to say the order of words in English, okay? But we should be able to reflect some embeddings in the sentences. So that is the idea behind UNL, created by Uchida after he had created the Atlas II system based on similar ideas that went to market in '83. Is still one of the best system for Japanese English and English Japanese in Japan now. And now that system has 7 million dictionary entries. So it scales up. okay? And that representation should be, in a way, alignable with text. So that's a problem with UNL in principle, because a graph is very difficult to align. But good news, I will show you that you can unfold a UNL graph into a UNL tree and fold it back. And this will give rise to a pseudo-dependency tree, deep semantic dependency tree that can be aligned. Okay, so okay, this is to show you that there are really in many systems different kinds of interlingua. Okay, I skip. Okay, so for 320 or more languages, we have to have some lexically disambiguated semantic pivot that is simple and not specific to particular domains. We want it to be quite generic, okay? So, UNL seems to be the best candidate. So, of course, I don't have a lot of time to show you about UNL, but simply here is a kind of graph for the dog watches its master. It's not a tree, okay? And here you have the linear writing by arcs. Okay? So this is the way we enter it in the computer, but to understand it, we draw a diagram. Okay? And something which is very interesting here, the possibility to have subgraphs called scopes that are connects graphs, connects by arcs without taking into account the direction on the arcs. Okay? And this enables you to have a very simple representation of something like this. John knows that Peter will not come and regrets it. It is a pronoun. It doesn't stand for a noun or for an adjective or whatever, but it stands for Peter will not come. And here Peter will not come is just two nodes, okay? And they are referred by this node called 01. Very easy, and you try to do that with all current, you put that in the pen tree bank, etc., or in the tectogramma tree bank of Prague, or the dependency tree bank of the Russians in EP. It's very complex structures. Okay? And here is a way to an illustration of the fact that you can unfold a UNL tree, a UNL graph into a UNL tree, right? So to bring in a new language in the system, for 320, we will first find some translation. If there is no need for any translation in the language, meaning they are not interested actually to equip their language for communication. So, okay, so good. But in general, you find people who want to translate things, even have articles in some newspaper translated, say, from French or English into their language, etc. So then we build an aligned corpus using the result of the human online volunteer translation. Okay? And you can use for that machine translation, even if it does not exist for the language, but does exist for a similar language. This is something we did for Korean, for Comorian, one of the 4 dialects, Ngazija, by post-editing Swahili output of Google Translate. Oh, it can work. Okay? Then you build some morphological analyzer, okay? And you align the morphosyntactic lattice and the UNL tree, provided you have the source, French, English, or Chinese, or Japanese, whatever, already annotated by UNL graphs that are supposed to be invariants as a graph, okay? So then when you build, those
we have
UNL...
2 minutes.
Okay, when you build those UNL trees, actually you can have a step of co-editing, that is, modify something in the text, reflect it in the graph, and deconvert again. Have some illustration of that, okay? So we have ACT will retrieve a coastal zone after a forum. This came from, I don't know, from Spanish, etc. And articles are wrong. We would like to have definite articles, okay, and the forum should be proper noun, etc. So idea is that the initial graph is like this, very simple, but it contains some error. It's not retrieve, but recover, not ACT, but DCT, and not A forum, but D forum. So we'll annotate this one by some co-editing facility, and then we will add on the graph some modifications, like add some attribute on the nodes containing city, forum, etc., add proper name, and replace retrieve by recover, okay? So the transform UNL graph in its linear form is totally unreadable, but in the graphical form, you see that it has been slightly amended, and now it will give the desired output in many languages. Okay, so you see, you have to start from for a line corpus of text and a good structure. That's the problem. And sometimes when you have a new language, you have to put on the graph some information you did not have before because it was underspecified in the source language. Like if you come from Russian, you have no articles, so you don't know what to generate. Okay? And I will show you how we can, and this is very establish correspondences between those say natural language sentences and here a UNL graph, which is a tree in this case. Okay, so the idea is that we will annotate both parts by lexical units of the other of UNL for English and about this one. So here I have the just representation enhanced. Then I can use the lexemes, okay, as anchors to establish correspondences. And I realized that some correspondences will link a node there and an attribute somewhere, or an arc with some value of a feature in some nodes, etc. You see maybe those blue lines, and the red are the elements of the correspondence, okay? And this is what we want to learn by neural nets, okay? So, and this is about, showing that to align the same UNL graph with a sentence in one language like French or English might be projective, but it might be not projective for another language like Chinese or, for that matter, Latin. Okay, and okay, I'm at the end. So that good news is that it comes from last MT Summit 3 weeks ago in Nagoya, that deep learning should really be applicable to do that kind of learning correspondences, and also implementing the resulting converters or deconverters, okay? Because here we can have the input-output layers for text and UNL tree. We can have up to 40, 50 vectors, actually, that are like complex nodes in the input layer, okay? And we can use internal layers to implement the what is called attention mechanism in neural nets, and represent also in some other regions the sub-problems, like in Cox algorithm, where we have half matrix, where each cell represents the sub-problem of analyzing some subsequence of the input, okay? So that's the idea here, okay? And I finish with the perspectives that are really now a big hope in a deep learning-based approach. We could start from some corpus that has been already annotated with more than 400 articles. This is 16 times 220 pages, so it's quite sizable, okay, on ecology. And then to equip a new language, LJ, then we have the speakers of LJ translate interesting text from a UNL annotated corpus. We transform them into morphosyntactic lattices, that is lattices of vectors, okay? And as a side product, we find UNL dictionary. And then we establish and we learn the UNL tree and lattice correspondences. That is actually correspondences with some trajectory in the lattice. And then we can learn and converters and deconverters. And the last two, we think now, can be done with neural nets far better than what we could imagine with statistical approaches. Okay, I'm finished. Thank you very much.
Thank you very much. Really, thank you very much for this very important talk about that shows the complexity of the phenomenon of natural language and also the complexity of techniques that we need, mainly in the application, machine translation. It's not easy, I know, especially for also, I think, the absence of enough resources is really an obstacle, mainly in the translation. We have slot for one question. A short question, please.
Okay. Thank you for the speech. Actually, I have been trying to manipulate Matière and Blue lately, and I've noticed that Matière, the translation module, the one you just talked about, Matière, M-E-T-O-E-R, Matière and Blue. The translation. Yeah, Matière and Blue. So those translation. Yeah, it's the last two letters are switched.
It has to be pronounced blue according to and then it is written B-L-E-U and not B-L-E-U. Okay. They have to be pronounced bleu and not blue. And it's written B-L-E-U and not B-L-U-E. This is what the authors, Papineni and the other one, I forgot, said in 2001 when they proposed this measure.
Okay, so I was trying to reach the dictionary of Matière to be able to process some Arabic language. And to tell you the truth, I only found they published accuracy level for the first three languages, which is Dutch, French, and English. I think the accuracy level was 0.8. But when it comes to Arabic, it's only 3. And nobody's doing any effort to tune those metrics to be able to enhance the performance for the Arabic language. So I don't know, is it the lack of data? Is it the lack of articles, the translators? I mean, what's the problem? Why it's not accurate when it comes to Arabic?
You don't have to tune anything to compute a bleu. What you need is simply two parallel corpora that is aligned at the level of sentence in whatever writing system, simply for languages that have no spaces between words, so they have no typographical words, but only linguistic words. You have to segment them, like for Chinese or Japanese or Lao, Khmer, Thai, whatever. Well, you have to segment them, right? And that's it.
But for
then
Matière,
you have
for Matière, you have to have the dictionary where you can reference.
No, but I mean that is of no interest. I'm sorry, but those measures measure nothing. They don't measure quality in particular. It has been proven said in an article in 2006. Title of the article is Re-Evaluating the Role of Bleu in Machine Translation Research. This one by Osborne, Callison Church, and Philippe Koehn, top in the domain. And they have proven that Bleu cannot estimate quality. Okay. They show very good reason for that, and so also experimentally it has been proven by many people before, including us for IW SLT 04. So Bleu cannot be really used for that, but it can be used to measure global progress toward the goal. When you are building some system, you have lots of references, okay? One reference per sentence, and you would like to know whether your system is in a way approaching that the references, and a bleu is easy to compute and quite a good indicator. But bleu, for instance, does not measure in any faithful way even the similarity at n-gram level between two individual sentences, the input and output. It does not. For that, you have, say, translation error rate, multiple translation error rate, HTER, etc. And for Meteor uses a dictionary of synonyms, etc. I mean, it doesn't give. There are papers on that, yes, but when you experiment with running systems, it's useless. You don't. But what is really useful is to measure according to the situation. For instance, time it takes to post edit, or time it takes to accomplish some reservation, etc., using a system compared with using a bilingual or pseudo-bilingual person like a Japanese clerk with TOEIC level 500 trying to help you. Okay, now we have a system like Voicestra with 27 languages, and Naritra is a version specialized for Narita Airport support to foreigners. And then you can measure whether the system will actually help you as much as a clerk of 600 or 500 or TOEIC level. See, that measure had been introduced by ATR in 99, 2000 after the CSTAR2 project. But,
I think we can continue the discussion later. Short question, short answer. Okay. Short question, short answer, please.
Thank you, Professor, for your informative session and presentation. Well, my question is, or my comment is that your architecture or this model actually accounts for syntax rather than semantics. What I mean by that, you can solve the syntactic problems on this model, but when it comes to the meaning, there's a problem, especially when you have cultural and social implications involved. So do you think this structure will be able to account for the social and cultural implications when it comes to translation in the future? Thank you.
Well, in many representations like that, in UNL in particular, you have some attributes that are of pragmatic nature. So they tell you about the kind of speech act, but also about, say, what people understand usually as politeness, and for Japanese it has 3 components like deference, humility, etc., respect. Okay, so you have them, and they are of pragmatic nature. They relate not only to a fixed domain, but to the communication acts. Okay, and this is social. For instance, you said that an agent should be very polite. When a Japanese agent will speak very politely to you, say something like honored guest or sama, etc. Use expressions that are particular to that, like irashaimase, etc. While the client actually will be quite rough.
Okay.
And also, so this, yes, you can take into account. Now, other things concerning the culture, for instance, if you have websites, etc., and you want to adapt to localize to Arabic, you might have a problem with the frames where you position them and with the colors, because the colors have different meanings according to the cultures.
Sure.
So in particular, you should not use, say, green indiscriminately, and you should not use red or black in some Chinese or Japanese context, etc.
In general, semantic analysis is really very complicated because we have a lot of things that can interfere in the problem. Okay, thank you very much. Thank you, Christian, for this talk. And I call my colleague Malik Qasaimi to present the next keynote speaker.